Welcome to this video on stacking ensembles for data mining tasks. I am the programming professor, and this video is part of a series of videos on data mining. In this video, we will cover several important topics. We will begin by introducing the concept of stacking and discussing its benefits and challenges. Next, we will explore the role of base and meta models in stacking. Then, we will break down the steps required to build a stacking ensemble. Finally, we will discuss how to implement stacking in Python using scikit-learn. Stacking is an ensemble method that combines multiple base models for improved accuracy. Base models are trained on the entire dataset, and their predictions are combined using a meta model to produce the final output. By using different types of base models, stacking introduces diversity and leverages their individual strengths. There are several benefits to stacking. It reduces errors by combining the strengths of different models and balances weaknesses. However, it also has challenges. Stacking can be computationally intensive, and the choice of the meta model significantly impacts performance. Base models generate diverse predictions, which are then fed into a meta model. The meta model makes the final predictions by learning patterns from these base model outputs. Examples include logistic regression for classification and linear regression for regression. An ideal stacking ensemble balances the strengths of its base models. Building a stacking ensemble involves a few straightforward steps. First, train diverse base models on the full dataset. Second, generate predictions from each base model. Third, combine these predictions into a new dataset. Fourth, train a meta model on the combined predictions. Finally, use the meta model to make the final predictions. This code snippet demonstrates implementing stacking using Python and scikit-learn. It defines two base models, a decision tree and a support vector classifier, and uses logistic regression as the meta model. The stacking ensemble is created, trained, and used for predictions, showcasing how easy it is to implement this technique. In summary, stacking is a powerful ensemble method for combining diverse models. Base models generate intermediate outputs, which are used by the meta model for final predictions. Meta models help smooth decision boundaries and balance the weaknesses of individual models. Successful stacking requires careful selection of base and meta models. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.